Okay, for 4-2, we're looking at solving these quadratic equations by graphing. The main thing is you're going to graph it, and then if you remember, your solutions are just your x-intercepts. Remember that roots, zeros, x-intercepts, and solutions are all talking about the same points on your graph, the same thing. Okay, so you're either looking for where the graph crosses the x-axis, or you're looking for where y equals 0. Okay, so now you actually already know more about this than they expect you to whenever you're working this worksheet out. So you can go ahead and just graph it traditionally if you want to. But again, if you would prefer, you could also factor this. So for example, this one's going to be x minus 7 and x minus 3. Okay, so I know that my solutions here are going to be 3, 1, 2, 3, and 7. 3, 4, 5, 6, 7. Okay, I know, so that's what we're using our solutions. The solution is going to be x equals 7 and x equals 3. Or you could write it as the point, 7, 0, and 3, 0. Either one, okay. And then again, if I was going to finish graphing it, I know the vertex would be here in the middle. What's between 3 and 7? Well, that's 3, 4, 5. Plug 5 in to find the vertex. It's going to be 5, comma, and then 5 minus 7 times 5 minus 3, or negative 2 times 2. 5, negative 4 is your vertex. 1, 2, 3, 4. Again, you could just do your normal points from there, and there's your graph. Okay, so it's not always going to work out quite so nicely. Going ahead and looking at question number 4. So again, you could go ahead and factor the rest of these and graph it and find your solutions. Honestly, since you kind of already know some things about factoring, if you want to factor it basically to find the solutions, then that's okay too. So looking here at question number 4, if I wanted to factor it, remember this is where I'm going to have to use that x method. This is going to be a 4, this is going to be a 4, so multiplies to be 4, adds to be 4 is a 2 and a 2. So whenever I squeeze that into my equation, 2x plus 1, and I factor, gives you that your two factors are 2x plus 1 and 2x plus 1, okay? Which means your solution is going to be x equals negative 1/2, okay? Or, again, if you would rather, negative 1/2, comma 0 is going to be right here. And then again, you can just do your normal points from there, except this one's been stretched. So it's kind of tricky to do the rest of your points. It might be better to plug some points in. For example, if I plug in 0 here, I know that this is going to have a y-intercept here at 1, which means that it must also be 1 on this side because it's symmetric. If I plug in, like, let's say a 1, and that's going to be 4 plus 1, which is 8 plus 1 is 9. So here at 1, it's at 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you could totally do it that way too if you wanted to. Now, if you wanted to do the traditional stretch stuff, you could do that too, but you have to remember that over 1 is actually going to be here in between, and up 1, 2, 3, 4, right? Over 1 and up 1, 2, 3, 4. Okay, so however you want to graph that. The main thing is to find your solution, which is right here. Okay, again, I'm not going to finish that. But flipping to the back, sometimes you don't know exactly where those solutions are. So for example, these equations cannot be factored. Okay, but I can still find, I can still estimate at least where my solutions are. So looking here at question number 5, this is the only one I'm going to do. Again, negative b divided by 2a. So in this case, that's going to be negative 2 divided by 2 times negative 1, or 1 is the x value of your vertex. Again, plug that in. So that's negative 1 plus 2 plus 4. Notice that this is still negative 1 because the negative's outside the parentheses. You're going to square the 1 and then make that answer negative. Okay, so 2 plus 4 is 6, minus 1 is 5. So the point 1, comma 5 is the vertex. So let's do that. Here's 1, and then 1, 2, 3, 4, 5. From there, I can plot my normal points. This is reflected, so 1, 1, and then 2, 4. And then again, if I was going to do the next one, it's 3 and then 9. So 5, 6, 7, 8, 9 down here somewhere. So looking at this, your solutions, you still have solutions. They're right there. They're just not at very nice points. So what we're going to do on these questions, you're just going to tell me that the solution is between what two numbers. So for example, here I'm going to say between, and then this one right here is between -1 and -2. Between x is -1 and x is -2. This one is between 1, 2, 3, and 4. Between 3 and 4. Okay? Now, this for some reason turns out to usually be pretty difficult for some people to do. I'm really not sure why. You have to talk about each little crossing individually, and then you're just telling me what these two numbers are on either side, what the x value for either one of those are. Okay, I've seen, like I said, some crazy answers here. Don't make it hard. Just tell me between what two numbers. Just like how here on the example, they said this one is between x is 0 and x is -1. This one is between x is 2 and x is 3. Okay, like I said, don't make it hard.